All right, so we actually finished the chapter 34. So we can establish when the next quiz is. About a week from today. So the 8th, and then spring break is the week after that. Oh, wait. Spring break starts on, it's Tuesday through Thursday, right?
Yeah.
That's where you're right, yay. So the quiz on 34, a week from today.
Are we counting the numbers then?
Yeah, I've got.
So just do a quick problem here. Most of you have calculators, so I have a convex mirror. Focal length is, you know what? Let's make it slightly more sophisticated. Radius of curvature. Equals 20 centimeters. And object will make 30 centimeters in front. Where's the image? And then we'll do the same with a concave mirror. Give you a chance to sort of work on it, and you will have two different answers. If you have an answer, just let me know and I'll walk over there.
the convex. Did I do it right?
The only thing I would get you on is the units. But, yeah, that's the right number.
Okay.
And for those of you watching this on YouTube, this is entertainment.
No. Radius of curvature is 20 centimeters, that's not the focal length.
That's, the radius of the curvature divided by 2 is the focal length, correct?
So it'll give you the magnitude, yes.
So what I put that, so putting it as 10 was correct?
Yes,
Okay.
for the convex. For the concave, putting it as 10 would be incorrect. Oh, wait a second, I did that backwards.
Yeah.
The answer you gave me was for the concave mirror.
That,
Your answer was concave mirror.
So for the convex, the focal point is gonna be negative, right? It's behind here.
Yes,
okay, so for convex, it would be negative 10 centimeters.
yes.
So then Q would be negative 15.
No. Because P is still 30.
Oh. Oh, wait a minute.
This one.
So the book says that for radius of curvature and focal length are considered a negative or divergent for convex mirrors.
Oh, I was viewing that's represented in the focal length, so I guess that is misrepresented here.
Okay, so negative,
So I guess that would be negative 20 with the book towards it. I'm gonna have to be careful with my wording.
okay, so negative 10 and, negative 15 for the convex.
I was viewing radius curvature as being just a physical property of, I've got a sphere.
Right, it's the magnitude of the
Yeah.
radius of the mirror.
I guess technically it then.
It would be difficult to have a negative radius.
Yeah, I guess in optics, they have their way of stating that stuff.
I think the only way we'd have to, the only way would be a negative radius or negative.
Right, for the convex. Yeah.
Yeah, okay. Okay, and then the column, okay.
Yes. And don't forget units on the quiz or test. Yeah, all right. Sorry about my backwards lenses are the flip in some sense, and so that messes with my head sometimes. Oh, there's the
I was
eraser.
just thinking about the clubhouse mirror. Convex should get smaller,
All right, enough of mirrors for right now.
yeah.
Unless there are any questions before we start on chapter 35. Yeah. All right, the key property of light is the fact that it refracts. That's the noun form for fraction. So that if I have some medium here, so let's say that this is air and water. Typically, when you do the angle at which something hits it is based upon the normal. So if normal meaning perpendicular, so if this is my surface, the boundary, and light is coming in, it's gonna hit at some theta sub I for angle of incidence. So this is the angle of incidence. Let's see to get this thing adjusted right today. And when it enters, it does not travel in a straight line. It will bend. So theta sub r, this would be the angle of refraction.
Yeah, I remember that one. I've seen, straws in glasses of water.
Yep. And you'll see that bend. Now what's happening here is that light travels at different speeds in different mediums. Now that seems to contradict the speed of light is absolute. But let's think about what's going on when it enters into a medium. Is that I have, let's say water's got a whole bunch of molecules here. Light comes in, it hits a molecule, and then will get shot out again. So it takes time for basically the atom to absorb the electron, absorb the photon and then send it back out again. And so different materials will take a different amount of time for light to get through it. Yes?
Is Cherenkov radiation an example of refraction?
No, that's, when light travels you get Cherenkov radiation when you have objects moving faster than light does in that medium.
Oh,
So Cherenkov radiation is if I can get a charged particle traveling faster than light can travel in that medium, then you get that blue light of Cherenkov radiation.
oh, okay.
Wait. Never mind.
Right. Now, nothing's supposed to go faster than the speed of light, but that's the speed of light in a vacuum. So there's this value of c, which is speed of light in a vacuum.
Oh, okay. I was wondering what that C was on the, homework.
Ah, yeah. And when you enter a medium, the net speed, because again, it gets absorbed and re-emitted, is defined by the speed of light divided by this constant known as the index of refraction. And so the speed would be c. Thus the index of refraction is some number bigger than 1, or 1 or bigger. Now this index of refraction of air is close enough to that of a vacuum that we can just assume that n is approximately equal to 1 here. I don't think there's a situation where we worry about the fact that it's 1.000, I think 4 or 5 zeros before you get to the first non-zero after the decimal. So let's think about the relationship here between these two angles and the index of refraction. And so, do the derivation. So let's tilt it this way. I've got my line going this way, and I have light coming in. So let's just go with, I have 2 light beams coming in. The distance between here and here, we'll just label as the letter h. That's the distance from here to here. I have some angle of incidence here, theta sub I. And let's go to the stunning effect. So this angle right here is theta sub I. So this angle down here, well, since this line right here, our reference line, is perpendicular to the surface, it's normal to the surface, this angle right here that I've got with the 2 strokes would have to be the complement. So it's 90 degrees minus theta over I, and I'm just going to label that as theta sub I prime. So just a quick note for the purists of the group, theta sub I prime plus theta sub I is equal to 90 degrees. I have a right triangle here, because if the light is, these 2 photons are emitted at the same time, then when this beam over here hits, that's where the other beam, so we'll just call this beam 1 and beam 2. So when photon 1 hits the surface, photon 2 hasn't quite got there yet. So we have an angle there, therefore this angle down here would have to be theta sub I, because I'm looking at this triangle. The right angle there, this is my complement of theta. This side down here is h, and this angle here would be theta sub I. So I'm making the claim that it's traveling slower in this other body of water, and that's why it bends at an angle. So by the time this light has gotten to here, this one has traveled not quite as far. I'm gonna dash that line. And this angle right here is theta sub r. The angle of refraction, because it bends.
Is that left leg of that angle, perpendicular to the surface?
This is perpendicular to the surface.
Okay.
Yeah. So the first photon number 1 has gotten to here by the time the second one actually hits the surface. Using the same logic as before, this angle right here would have to be theta sub r. So basically I have a second triangle. That's a right angle there. Let's see if I can actually draw that a little bit better. This angle here is theta sub r, and that's h. So let's take a look at some distances here. On this first medium over here, we'll just say that the index of refraction is n sub 1, and down here n sub 2. Or let's, for some consistency, n sub I and n sub r. So the distance, since this is in medium number 1, whatever's above this surface, this distance here is going to be, well, distance is speed times time, and so the speed is c over n sub I times time. Down here, it's the same amount of time, so this is c over n sub r times time. That's this distance. But more importantly, we have this h that's common to these two triangles, the one in the medium surface, above the surface and below the surface. So if I look at the sine of theta sub I, well, sine is opposite over the hypotenuse. Well, that's my opposite side right there, c t over n sub I over the hypotenuse, h. Sine theta sub r is opposite over the hypotenuse, so this is ct over n sub r over hypotenuse. So this would then simplify down into ct over h n sub I, and this is ct over h n sub r. Obviously, we have a bunch of stuff that's common to the both of them. So let's do some division. We'll divide the signs and we'll divide these fractions over here. So if I divide the signs, I have sine of theta sub I over sine of theta sub r. And on the right-hand side, I have ct over h n sub I over ct over h n sub r. Don't forget, when I'm dividing fractions, that's the same as multiplying by the reciprocal, so this becomes ct over h n sub I times h n sub r over ct. And let's see, make sure I didn't mess up somewhere. And I feel like I got something off. Alright, so what did I do? Alright, so sine is opposite over the hypotenuse. here, just figure out where I got something backwards.
Me too.
Let's see where I am, okay.
That's easy, good idea. The book's not in that bad condition. It's not in, aren't they?
I got something. Let's see.
That's what you get for paying for $11 for it. What'd you get it at?
Yes, yeah.
That's right.
Yeah, keep the box, you just get the label off and drop it out. That was really fun. Okay. I can get you a box.
I might have something.
Save them $40.
Let's see how that's an extra gas. See if I want to keep this. Sharp's still on the case. It's
I'll get you a take it.
Did that.
like, we don't want this stuff. I hate that stuff. Yeah. Oh, you're charging $75 for this use. Yes, yeah.
So, this is clean.
Don't buy it.
You have a record?
Yeah, we do.
I want to get a record player.
Oh, okay. Sorry. No mistake. So we're now here. So H cancels out, C cancels out, T cancels out, and what I'm left with is NR over N sub I. Cross multiply, I get N sub I times the sine of theta I equals N sub R times the sine of theta R. Or I did incidence and refraction. I mean, you could do 1 and 2, so N1 sine theta 1, or whatever the first surface is equal to N2, our medium is sine theta 2 for the second medium, and this is known as Snell's law. So over here, if we did air and water, if my angle of incidence is, let's just say 37 degrees, at what angle will it be going through the water? Well, my index of refraction of air is close to 1, so I have 1 times the sine of 37 degrees is equal to the index of refraction of water times the sine of my angle of refraction. And so for water, there's going to be a table in the book. There we go. Water, 1.33. You're not expected to have them memorized, but short-term memory probably would help. And so we have sine of 37 degrees which is about 0.6. Over 1.33 is the sine of theta r. And so theta r becomes the arc sine of this. That's roughly 4/3, so you got arc sine of around 0.45.
Yes.
Yeah, about 27 degrees.
27 degrees, all right. So this becomes 27 degrees. Likewise, if I instead having the object in air but had it in water, in other words, just reversed it, if it comes in at a 27-degree angle, it's gonna come out at a 37-degree angle. So when it goes to a greater index of refraction, it gets closer to the normal, and if it goes to a lower index of refraction, it gets farther away from the normal. And, yes, Holden.
I don't know if this would be appropriate for, this question would be appropriate for now or for after class, but, I'm just wondering, what the importance